All right, so here we are continuing 2.4, part 2 for Math 9. And this chart looks very similar, doesn't it, to the one we did the other day? Was it just yesterday? Last class anyways, when we worked on this. This is very similar, except we are not multiplying, okay? It's not a product. It is these are quotients, okay? Do you know what quotient means?
Division.
Yeah, quotient means the result when you divide, okay? The result you get when you divide. So quotient means division. Product is the result you get when you multiply, right? All right, so let's fill out this chart. Well, actually, let's just examine the first row that they give us here. And if you guys need to turn the lights off back there, you go ahead if that's screen's too washed out for you. Okay, so we have, again, a little difficult to see. Let me zoom in for you a bit. We have 10 to the power of 5 divided by 10 to the power of 3. So just like yesterday, we have the same bases involved. Different than yesterday, we have division involved. But look carefully at what this means. 10 to the power of 5 is still written in repeated multiplication as 5 tens multiplied together. Okay? The divided by will be written as this line right here. Okay? That's the divided by line. And in high school math now, I know up to this point, perhaps you've been used to doing this, 10 divided by 2 equals 5. We don't write it like that anymore, okay? In high school math, you don't write it like that anymore. That still means divided by, but instead what we do now is we write this as 10 over 2, or 10 divided by with that line, okay? And it can be slanted like this, or it can be just straight over like this, all right? But more often than not, you're going to see this. You're not going to see divided signs anymore, because when we get into calculus, right? When we get into like high school, grade 12 calculus, there's no room for those divided signs. It has to be a big line over like that. So we're kind of moving away from that. So this is what it means. Now 10 to the power of 3, that's 3 tens multiplied by each other like this. Okay, now what's neat here, and hopefully you remember this, but if, and again, you guys will have to tell me if this is something you remember or have learned, but if I have something like 10 over 2, that can be written as 5 times 2 over 2. Okay? That's what 10 is, 5 times 2. So I can write it like that. Now, I see that if I have a 2, a factor that is a 2 and a factor that is a 2 on the bottom. So we have the same number that's in the process of multiplication on the top and multiplication, let's say, on the bottom. If they're the same, they can divide out as 1. Because this can be written like this. 5 times 2 over 2. Okay? And 2 over 2, of course, is just 1. So that's why 10 divided by 2 is 5. That's how we show that. Okay? And that's called dividing out common factors. From the top of a fraction called the numerator, with the bottom of the fraction called the denominator. Okay? The denominator. The denoms in the pit, okay, on the bottom. But so if you take a look at how we can now divide these out, look at the ones right on top of each other. Look at this. There's a 10, there's a factor, there's a 10. There's a 10, there's a factor, there's a 10. And we have another pair that we can divide out to make 1, and when we multiply them by 1, it's like it's gone, right? So we don't eliminate them necessarily, we divide them out. And what we're left with on top is 10 times 10. And really, this is all over 1, because this is 1 over 1, 1 over 1, 1 over 1. So we have 10 squared over 1, which is just 10 squared. All right? Long drawn-out explanation for this, but hopefully that makes sense. Let's do the next row. Let's do the next row. Going to be a little bit of writing, and some of you maybe have started this already. So 10 times 10 times 10 times 10 times 10 times 10. 1, 2, 3, 4, 5, 6, 7, 8 tens, right? 10 to the power of 8 on the bottom. I have it. I'm going to start on this side too. 10 times 10 times 10 times 10 times 10. That dividing out, those two can go. That's a 1 over 1. Those two go. Those two, those two, those two. So what am I left with? 10 to the power of? 3. Okay? Now I know you guys are lightning smart. I know you're lightning smart, so you're already getting the picture. You already see, you know what happened yesterday. When we multiplied, what did we do with the exponents? We added the exponents. When we divide, Any idea of what we might do with the exponents when we divide? You have a 5 and a 3. Yep. Yes, you subtract the exponents. Okay, always start with the first one and subtract the second one. Okay, so let's do this one. Okay, I mean, you guys can fill this out. I don't know if we need to do this all, but let's do the last one. Okay, so 4 times 4 times 4 times 4. That's 4 of them. Times 4 times 4 times 4, and over 4 times 4 times 4 times 4. Now, if you like this, you could do this. You could put brackets around 4 of these and brackets around all 4 of those in the bottom and see that they all divide out right away, just like that. So we're left with, 4 to the power of 3, which of course is 7 minus 4, if you want to think about that. The divided by sign has that little minus in it. You can maybe remember it that way. Okay, any questions about that? Okay, as yesterday, does it work if we have different bases? So if I have 5 times 5 divided by 2 times 2 times 2, is there any rule, or does this rule apply? No, it doesn't. Why not?
Because it's different.
Different what? Different bases, right. If they're the same bases, great, we can do it. But if different bases, can't do it, okay? Question?
Because, just comment.
Yeah.
If for the first question, we have 10 over 10 in front of them, so they cancel each other out. 5 can't cancel out 2.
Right. That's exactly right. And that's right, because we can't do this. 5 and 2 cannot simplify or divide out to be 1. They're not the same, so we can't do that. We can't even do 5 divided by 2 times 2. That's not 5. That's 4. So that doesn't work. So there's no factors or groups of factors that we can divide out or simplify. So we would just have to write this as 25 over, what's 2 cubed? 8. Very good. 25 over 8. And that's the way we'd have to leave that. That's simplified. We're done. Okay? Yes, it's simplified. Yeah, so you're right. Okay, so here's the exponent law for, wait, what? Exponent law for product of powers? That's from last day. Oh, wow. Did not even notice that. Okay, whoops. So this should be exponent law for quotient of powers. Wow. We're going to have to fix some notes here, I guess. So please change that. Quotient of powers. Yeah, you notice that? And instead of a times a to the n, let's just redo all of that. If we have a to the power of m divided by a to the power of n, as long as they're the same bases, we can simply subtract the 2. So that's your exponent law for quotient. Okay? And yeah, I'm gonna have to fix this, sorry, but this also is divide. So if we divide powers, we subtract exponents. There you go, you learn something new every day, don't you? Okay. So any questions there right now? Are everybody understanding this, or is there any clarifying questions? Did I miss something? You guys are good? All right. Okay, let's get some practice then. Here's some practice down here. So write as a single power, then evaluate. So I have the same base. I'm dividing those powers, so I can write the base of 2, and that's going to be to the power of 5 minus 2, or 2 to the power of 3. And if I were to evaluate that, that is 2 times 2, which is 4, times another 2, which is 8. So you should be memorizing 2 cubed is 8. That should come pretty quick now. Your squareds and your cubes, you should be memorizing those. You should know up to 10, probably, for squareds, for sure. I would encourage you to learn up to 20 for squareds, but that can come eventually. Kind of know up to 10 for sure. It's just your multiplication tables. Cubes, well, you should have 2 cubed memorized. 3 cubed you should have memorized. That's 27. 4 cubed, we don't use that much, but that's 64. So you can go maybe to 5. 5 cubed is 125. If you go, 2 or 1, I guess 1 cubed is 1. But 1 to 5 for the cubes, memorize those. 1 to 20 with the squareds. Try and memorize those. Put them on a piece of paper. Every day when you go home, you do your math homework, get out your piece of paper. Study them, memorize them. Try and say them without looking. A little bit every day. That's how you get good at math. Okay? I was so-so at math when I was your age. Just so-so. I mean, I understood. I didn't work very hard at it, though. I was busy. I was a sports guy. So I didn't do as much homework as I should have in high school. I wish I would have done more. But now that I've been doing this for more than 2 decades, I'm actually pretty decent at it now. But that's not because I'm so smart. It's because I've practiced so much. So the more you practice, the better you get. With math or basketball or hockey or tennis, ping pong, chess, I don't know. You name it. The more you do it, the better you get. Okay. Right is a single power b. Let's go. This is -6 to the power of what? Shout it out. 2. That's right. -6 to the power of 2. I probably should include these brackets so that no one is confused about whether that negative is part of the base, right? Keep your brackets in there. Awesome. Uh-oh. Uh-oh. We got trouble here. This is tough, isn't it? 3 to the power of 4 divided by 3 to the power of 4. According to the... Okay, wait a minute. This is actually a huge moment right now, okay? Whatever this number is, 3 to the power of 4, do you know what that is?
27. No.
81, thank you. 3 to the power of 4 is 81, because 3 to the power of 3 we know is 27 times 3. Tricky one, 81. But this is 81, and guess what's on the bottom? 81. So what is a number divided by itself? 1. That's always 1. Well, I don't know if that fits with our rules here. What do you think? This is going to be a base of 3, and then what I would have to do according to the rules is take 4 and subtract 4. Oh, that's going to be 3 to the power of what? 0. Uh-oh, is that 1? Ah, we learned that already. That is 1. Excellent. Da, da, da. 81 divided by 81 is 1. And there. Now, I think I told you last week when we were talking about powers of zeros, I said when we get into the exponent rules, I'll be able to explain this a little bit easier, or it'll all make a little bit more sense. So this is why a base to the power of 0 equals 1, because this rule right here, okay, if you back that up, this is the same quantity on top as it is on bottom. So when you divide those, it's always 1. That's why 3 to the power of 0 is always 1. All right. Example 3, you might be ahead of me already because I'm talking so much, but this is 12 to the power of 6 minus, there's no power there. What is that? Is that a 0? What is that? If there's no power shown, what is it understood to be? 1. You guys are so smart. That's 12 to the power of 5. All right. Now, just right as a single part, you don't have to evaluate that, so that's good. 12 to the power of 5. Oh, we didn't evaluate b. Okay, that is right. Thank you. This is, what's the evaluation here? -6 times -6 is positive 36. Very good. 36. Did someone say 38? It might have been 38 years ago, but now it's 36. Just kidding. Yeah, it's okay. All right, what about this one? 8 to the power of, oh no. This is going to be really hard. Look at that. That looks so difficult. Is it tough? Yeah. Hey, wait a minute. No, it's not. 3 minus a -2. Now, do you know how to do that? Do you remember how to add and subtract integers? What's that like? That's like 3 plus 2. Perfect. That's like 3 plus 2. So that's 8 to the power of 5. Now, if you don't believe me, I'm going to get my fancy schmancy calculator out here on the screen, and I'm going to do that for you. So 8, okay, you know what? I'm going to use brackets here. Bracket. 8 to the power of 3 divided by, another bracket here, 8 to the power of -2. Let's try that. 32,768. And let's see what 8 to the power of 5 actually is. Oh, good. It's the same number. So that is correct. That's one way you could check that. Okay. C says 1.4 to the power of 6 divided by 1.4 to the power of 2. Well, 1.4 is our common base. Doesn't matter if it's a decimal, whole number, negative number. It just can't be 0, okay? Can't be 0. 0 is a base, no worky, okay? That no worky. But anything else is a base, okay, the rules still apply. So it's going to be 6 minus 2, 1.4 to the power of 4. 6 minus 2, 1.4 to the power of 4. All right. Let me know if you have any questions about that. So you do D and E on your own if you haven't yet. And I'll show you the answers in a second.
No.
Okay, that's what I got for D and E. Check with yours there. All right, so next page, just some clarification on standard form, exponent form, but also we're going to combine some of these laws together now. And am I still frozen there? Good. All right, so make sure you're answering the question in the correct way. All right. Okay, girls. Shh, quiet now. Evaluate means to find the answer in standard form. Okay? Evaluate means find the answer in standard form. We know that you get a number. So evaluate 4 to the power of 3 is showing the number answer. Right there. That's what you circle. That's the final answer. Evaluating 2 cubed times 2 squared is not leaving it as 2 to the 5, but evaluate means to simplify to a regular number answer, not necessarily a power. So 32 would be your answer. Express as a single power means write it in exponent form. This is all the examples that we've been doing. This is the terminology we've been using. So exponent form or as a single power. Remember, this is a power with a base and an exponent. All right. Example 4. Evaluate. Okay. Number answer. Now we have more than one type of operation here, so let's combine. Order of operations is bedmass. Remember, bedmass. So we have multiplication and division here, and that's where it fits in here. We have no brackets, well, we do have exponents, but we're going to use the exponent laws. So really, we are going to take care of the exponents, but we're writing them, we're going to do that, evaluate that after. So we're going to use exponent laws to simplify. So that's one place where you don't have to evaluate exponents first. We are just going to use our exponent laws, so that comes right here, okay? So we do division, multiplication, whichever one comes first if it's a row of operations. So we're going to group the first two, and I'm going to simplify that, and then I'm going to rewrite just this last part. So what's 8 to the power of 12 divided by 8 to the power of 7? 8 to the power of 12 minus 7, which is to the power of 5. Very good. Times 8 to the 2. So we'll rewrite what we haven't touched yet. Okay? Now I do the exponent laws for multiplication, right? 8 to the, what's that going to be? Yeah, 5 plus 2, 7. Perfect. And now evaluate. Okay, so these are larger numbers. We're going to try in most cases, try not to use a calculator. This one you probably have to use a calculator for. You don't have to have this memorized. That's 8 times 8 times 8 times 8 times 8 times 8, 7 times. So we can use a calculator for this one. 8 to the power of 7 is a very large number. 2097152. 2097152. Okay, B. Now, if it's written like this, okay, what do we do? Do we do the division first here with one of those, let's say, and then do the multiplication afterwards? As a matter of fact, if they're all the same base, it's okay to do it that way. But that's a little bit awkward, right? And sometimes when there's lots of different operations, it gets a little tricky. So what I would always suggest is try to focus on the numerator alone and evaluate, or at least simplify using exponent rules. Do the top first, squish together the top, simplify the top a little bit, and then simplify the bottom or denominator separately. Do those kind of first and second, then you can do that division afterwards, okay? Technically, you'll still get the same answer if you do this first and then multiply this quotient by this, but again, trust me that later on, you're not going to want to do that. It's going to be a little tricky. So let's do the top first. And this is going to be 2 to the power of what? What do you think?
8.
Yeah, 3 plus 5 is 8. And then divided by 2 squared. Okay? So what's this answer now? I got to keep going. This is 2 to the power of? 6. Very good, 6. That's 8 minus 2 to the power of 6. 2 to the power of 6. We probably don't need a calculator for that because we can times 2 pretty easily, even in our heads, right? So 2 is to the power of 1. 2 times 2, 4, 8, 16, 32, and 64. Very good. So this is 64. And then one more is just, you keep doubling. Keep doubling. So it's pretty easy. All right, any questions about those two? All right, you may need to use your calculator for some of these, and I don't mind if you do. That's no problem if their numbers are too big. But why don't you go ahead and do these 3 on your own. See if you can get the right answer. E looks really tough. So E you're going to have to be careful with. I want to see what you do with that. Okay? But go ahead and do C, D, and E on your own. And I'll show you the answers in a little bit. All right, let's see. There you go. So for C, I kind of left this alone because that's addition. You notice that? So don't do this one first. You probably should do this one first, the 6 to the 3 times 6 to the 2. So that's what I did here. I did this one first. And then you have to use your calculator probably to get this one. 7, 7, 7, 6. Add 36, which is 6 squared. 78, 12. Anybody else get that? You guys get that number? Okay, good. All right, this one here, again, let's evaluate the top first. Nothing to do there, just rewrite it. The bottom, you could probably evaluate that. And if you add the numbers there, you get negative 4 to the power of 6. And so what do? I take the same base, I subtract the exponents, right? So I get negative 4 to the power of 4. That's going to be a positive number, 4 to the power of 4, 256. Anybody else get that? Yeah? Good? Good. Right? E, this one looks tricky. You can rewrite this middle part, but you wouldn't have to. So I just took a look and I saw the brackets here. So is there something to be done inside the brackets? Yes, it does include using our rules, our laws. So that's what I did first. So this one you do first, right? So negative 10 to the power of 6 minus 4 is 2. So I rewrote everything else. I'm noticing a couple things as well, that this is now multiplication here between these two. And this is subtraction, so I'm definitely going to do the multiplication first. Same base of negative 10, 4 plus 2. Now some of you might be wondering about the bracket situation there. Do you have to use the square and round brackets? Not necessarily. The reason why I did that is because sometimes using the same brackets multiple times in a question can look a little confusing. That's why they did it, that's why I did it. But if you did it like this, that's fine. Even if you drop those brackets and did it like that, that's the same thing too. Just be careful with your brackets, because brackets often segregate some operations or values. And if you just drop them, sometimes you might miss a negative sign or something in there. And that's, again, as you move forward in math, make sure you don't just randomly drop brackets. There may be something to simplify if you take brackets out. In this case, it's the same if you have double brackets or not. Doesn't matter. So we'll do the multiplication, negative 10 to the power of 6. Remember, that's the same as writing 10 to the power of 6, right? Because that negative, it's multiplied by itself 6 times. It's an even number of times. So that's the same as 10 to the 6. I just wanted to rewrite that so that you remembered that, hey, those are exactly the same. So that's okay. And then 10 to the 6 minus 10 to the 7. 10 to the 6 is 1 followed by 6 zeros. So that's 1,000,000. And 10 to the 7 is 1 followed by 7 zeros. That's 10 million, right? And so if you do that subtraction, you actually get a negative number. 1 minus 10 is negative 9. And you're talking about millions, so it's negative 9 million. All right, did anyone get this for an answer for E? Okay, I see some nods, but a little less emphatic, so maybe more of you are a little unsure about that. Okay, well, that's part 2. That's part 2. If you divide powers with the same base, you simply subtract the exponents. Remember your order of operations. Remember that to the power of 0 equals 1, blah, 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 blah. Got it? Any questions before I give you your rest of your assignment here? All right. Today's assignment is on the board. Any questions before you begin?